To look out at horizon is to look out forever. Your eyes glance over an ocean, miles and miles of blue. Birds duck in and out of the swell. The pot of dolphins breach, plunge, and play in the sea foam. To look at a horizon is to remember how expansive this world is. But today, we're going deeper, below the surface, down to the ocean floor. As the light dims and the pressure builds, we find ourselves in the world of tiny microscopic organisms, algae, bacteria. This story is all about the hidden ocean and what its microbes tell us about the resilience of our planet and our future. To shine a light on this hidden world, today I'm joined by Dr. Allison Fong and Dr. Andrew Thurber, who are part of the Rolex and National Geographic Perpetual Planet Ocean Expedition. I'm Alex Honnold, professional rock climber and founder of the Honnold Foundation, bringing you stories of inspiring people who are helping to solve today's most pressing conservation issues. In partnership with the Rolex Perpetual Planet Initiative, this is Planet Visionaries.
I'm Ali Fong, a National Geographic explorer, biological oceanographer, and polar ecologist. And I study the incredible microbes that live in our planet, especially those in the ocean.
I'm Andrew Thurber. I'm a National Geographic explorer and a deep sea and polar ecologist. And I spend my time trying to understand the world's ocean, especially the deep and cold parts of it.
I actually really enjoy being away from the buzz of everyday life and getting out into the wild places. They're not necessarily pristine, but they're places that are far away from what we see every day, and they require close attention, no distraction. And when you're in isolation, you can really do that completely, comprehensively.
When I have the opportunity to sample the seafloor, and especially the deep sea floor, I'm looking for what's never been seen, what it does for the planet, and how it works in a functioning ocean. One of the things that I find really surprising about methane is even though it's an invisible gas, in many ways it connects us all. There's vast quantities of it in the ocean, and we want it kept in the ocean and as an energy source for weird animals rather than getting into our atmosphere, because if it gets into the atmosphere, it can cause the planet to warm at an unprecedented and scary rate.
The first sign that sea ice is in distress is the fact that it's melting, and it's melting rapidly. This is particularly true in the Arctic. We're also starting to see this trend in the Antarctic. And it's melting so much faster than it has in the past 3 or 4 decades of our record. So that's the first signal that says, hey, this ecosystem is in trouble.
So when I spend months at sea and sometimes months on land in frozen parts of the planet, I realize a couple things. One of those, the planet is beautiful in every single aspect. Frozen ice scapes all around me, seeing beautiful, colorful organisms at the bottom of the ocean. And these are glimpses into the planet that nobody gets to see except for us. And so I always try to share it any way I can.
Let's just get straight into it. Tell me each what you do. Tell me about your work.
I'm Ali Fong. I study the microbes of our planet, particularly those that live in the ocean, and all of the incredible things that they do.
I'm Andrew Thurber, and I study the deep and cold parts of the planet. And I really want to understand how these far-flung reaches of the globe impact us all as part of society, and really how they connect us all, even though they're not something we see on a daily basis.
Talk about what connects your work and what's different about each of your work.
Well, Andrew does animals as well, but the part where we overlap is probably 2 big things. One is the polar regions, so the extremes of our planet, and studying places that are very icy and cold. And probably the second is microbes. I consider them the unsung heroes of our world. And certainly the ones that live in the ocean are doing incredible, kind of crazy, mysterious things. And my work is about kind of discovering what processes they do, both the ones that we know about and how well they do them in different environmental conditions. And then on the flip side of that is all of the microbes that exist, but that we know very little about, and trying to get closer to understanding what contributions they're making to our ecosystem. So we might not know of them in the way that we know who they are, but we know that the product of their work
the
is
function.
visible. The function is visible in our ecosystem, and it's well-being.
Like the dark matter of biology.
It's true. There is this gap, right? It is this sort of amorphous gap. And okay, we know that they're there. We know that they're active. We know that they're probably interacting with one another and other organisms in the system.
But you haven't found
But we
them
haven't
yet.
figured out exactly how they do what they do, right? And so that's that ongoing question of how do they do that? What are the mechanisms? What's the physiology? Exactly.
And so, how does that contrast with your work?
Yeah, and so working with Ali is great because Ali really works in the surface ocean and especially the parts with ice, and I work in the deep ocean. So we're really connecting the entire water column together by the work. And I think one of the exciting components of working with microbes is in many ways we know they're important. We can follow the chemistry. We can know that, microbes from the ocean provide half the air we breathe on the planet, right? Like it's hugely important.
That seems important, yeah.
Yeah, really important.
And that's
if you
true?
feel like
The
breathing
microbes
today.
in the ocean provide half of our oxygen?
Yeah, the photosynthetic ones. Every other breath that you take is because of algae that lives in the ocean.
Through this whole episode, we should have this breath brought to you by
Should have,
algae
like,
in
a
the
little
ocean.
pause. That's right.
Yeah.
And
Sponsored
then a
by.
pause, and then this breath brought to you by algae in the ocean.
Yeah.
Okay.
And then also, like in the deep sea, a lot of the things that sort of rot over long timescales, like thousands of years, it provides these nutrients that organisms that Ali studies then use to essentially fuel entire fisheries. So it's really this integrated ocean understanding from the surface all the way down to the bottom that allows us to understand, like, how do we get the food that we eat? How do you get the air we breathe? How is that changing? And how can we try to use some sort of new techniques to be able to conserve it, understand it, and try to give the ocean as much of a chance to help us live here as we can?
Yeah.
So what drew each of you to science? Why are you each interested in that particular field?
Yeah. So for me, I've always loved science. Like it was one of my favorite subjects in school, right? And then I found out that I was actually pretty good at it. So it's sort of this process where you like to do the things that you like to do. And then if you end up being good at them, you're like, oh, maybe I can do this. And then the big thing was, how do I stay by the ocean for the rest of my life? I grew up in Rhode Island. No one in Rhode Island is more than 20 minutes from the sea. And I loved being around it. I loved recreationally, just loved it. And so it didn't occur to me until I was a little bit older that marine science could be a thing. People ask me what science is really about. And I go, people pay you to ask questions.
Yeah. And so what was your path?
So I sort of went a slightly different way. I've just always loved the ocean. Like I had an opportunity when I was 5 to go tide pooling in British Columbia with my family and snorkel in British Columbia and every other place. And so I just always wanted to spend my entire life in the ocean. And I never knew that I should get on a different path. And so I just sort of fell into this role of studying the ocean. And then as I got further along, I started to really love the complexity and the challenge of it. Like there's all sorts of strange interactions that are unknown. And then you can sort of tease those apart. So there's the constant challenge. And then at some point, there was this added in adventure and the ability to start going and seeing beautiful places as part of what I get to do for work.
It's funny, everything you guys say remind me so much of being a professional climber. We're sort of like, oh, I love doing that thing, but then you get to go on these cool adventures with these cool people and it's incredible experiences and these, I mean, it's exactly the same path, except yours are probably slightly more productive, where you actually like solve, ideally answer questions about the way the world works.
I think some days we come up with more questions than we solve.
Yes, exactly.
But the goal is always to make progress in the right way. And then also, I think as time's gone by, I realize that we're really lucky in that we get to see these corners of the planet. And so we get to share imagery and stories to try to get people to care. Because like, who cares about Antarctica? I mean, I can say I do, but other people are like, well, it's just that frozen wasteland on the bottom of the planet. You're like, it's the most beautiful wasteland on the bottom planet you can imagine. Like
the most beautiful wasteland you've ever seen. It's funny, I've only been to the interior of Antarctica for 2 different climbing expeditions, but in the interior, it is like a desolate wasteland. We spent like a month climbing granite spire type things and didn't see, actually we saw snow better. We saw one bird that comes like way inland to nest. And then I thought I might have seen a lichen one day where I was like, this could be a living thing, but you couldn't tell for sure.
Not.
I was like, I didn't think it was. So how did each of you, you're both on this path in science, how does that get you to where you are now? Like at what point do you start investigating these particular, your interest in microbes in the ice and yours in the deep sea?
I went from marine biology, so getting away from kind of the animals, into oceanography, which is more systems-based. So it's like the complexity of how things fit together and work and interact with one another, which is what I loved. And then grad school was all about understanding how the flow of carbon and nitrogen, which are 2 essential elements in our planet, flow through the food web, and particularly through the food web that is controlled by microbes. Then I figured out that unlike some animals, say lobsters, microbes exist everywhere in the ocean, right? So I could go anywhere. And so when that clicked in my head, I was like, oh, this is good. did my graduate work at the University of Hawaii, spent a decade out there enjoying life, loving it, and then decided, where can I ask these questions about microbes that's completely different, going to get to a new community, a new environment, like really push it. And so I went to an institution in Germany that specializes in polar science. And that's how I ended up working in polar science for the last almost 12 years. Yeah.
Is it hard to go from Hawaii to the poles? You're like, wow.
Yes, it is. They're like, you're going to need more gear. I was like, oh, okay. They're like, board shorts, maybe for sauna, but that's about it. These are going to be useless otherwise.
And Andrew?
Yeah, and it's interesting. There's actually a lot of sort of similarities in our paths. So I did my undergraduate work in Hawaii, and I saw a retirement ceremony of somebody, and there's a picture of them diving under the ice in the Antarctic. And then like 6 months later, somebody was like, do you want to go dive under the ice in Antarctica? And I was like, yeah, that sounds good. And so I went and I dove there. Diving there is really spectacular because the visibility is the best of the world. It's literally the clearest water at the end of winter because there's been no sunlight for 5 months of the year.
So nothing grows.
So nothing grows
at that time.
So there's just nothing in the water.
Yeah.
It's like clear.
And so I thought I was going to be really worried about the cold and like you're diving through an ice hole that you really need to get back out of. And that wasn't my experience at all. You drop through, you can see landscapes underwater. It's the only place you can see on the planet that I've ever seen that. So I was thinking like, you look down and there's just life everywhere.
That's in such contrast to my experiences in Antarctica. Like, really?
I mean, Antarctica, it's crazy because like on the surface, there's nothing. Like every once in a while, a penguin will walk by and that's really cool, but that's the only life you see. And then underwater, like you can't put your finger anywhere without hitting an animal. Like it's just everything, even the bottom of the ice.
The undersea life in Antarctica is comparable to anywhere else, like big reefs and tropical things and whatever. Like there's life everywhere.
Well, it's life everywhere, but it's also different life because when Antarctica pulled away from the rest of the planet 25 million years ago, it created this barrier. And then there's been separate evolution in the Antarctic versus everywhere else. And so stuff is strange. Like the predators, sea stars, they're like the lions of the Serengeti, except they're
very slow.
They're very slow. Actually, they're not that slow. They're really voracious predators.
Sea stars are voracious predators?
Oh my goodness,
You mean the pretty,
the things that look, they're beautiful, but they're great. They're such good, they're great at like lawn mowing, like a complete area of other prey items.
These little red, beautiful pincushion stars. My favorite story is the people I got to work with, Dr. Stacy Kim, who is one of my mentors. She was trying to tag them to see how much they moved. And so you put these little tags in them. And we do this all over the world, and then you watch them. As soon as she tagged one and put it on the seafloor to watch it, how much it moved, all the other ones of that same species, beautiful little red stars, thought it was injured and ate it. So like, they're really like amazing top predators.
Okay.
But then with that, I was like, well, how's everything alive? There's no food. Like there's nothing in the water column because you can see 300 feet.
Because there's no sunlight, and so there's no plant life.
So there's no plant life. And I was like, well...
So there's a lot of food though. But see, that's the tricky thing. There's a lot of food at a certain time of year.
What I realized was like the only thing that's in the water right now is bacteria. And then so there's still bacteria, even if there's no microbes that are catching sunlight. And there's, 1 million bacteria in every milliliter of seawater. So that's a food source.
And is that what the creatures are eating?
Some of them are.
Some of them are.
Some of them are.
Okay.
Especially those big
great
sponges.
Food item. Yeah, they filter feed, right?
Okay.
They like pass it's just like an air filter, right? So like we can't necessarily see all of the particles in the air. And just as Andrew was describing when he was diving, the water is super clear. But that's because all of the organisms that are there are microscopic ones. And so there's trillions in reality, but 1 million per drop of seawater. And then those big sponges or other types of filter feeders are like basically filtering that water and collecting all those small particles.
And eating them.
Well,
digesting
they've
whatever.
got carbon and they've got all those essential nutrients in there. And then when you have enough of it.
Small.
They're so small. So it's a lot, right? So they're almost constantly filter feeding.
How do you do this work?
Yeah.
That's the next step of like where I went in my career because I wanted to figure out how do you look at the role of microbes. And one of the cool things about methane and habitats fueled by methane is methane has this really unique signal that you can track into things that eat methane. And so it actually dragged me from the Antarctic to the deep sea because I literally just wanted to understand who's eating microbes. And they have this really cool chemical signal that anything that eats it carries on. And so I started out getting to look at methane seeps, these areas where methane is released from the seafloor and is a chemical energy source for strange biology, just to try to answer sort of an esoteric question of like, what do worms in the deep sea eat? But then as I thought about that more and more, I was like, well, they're actually eating methane, and methane being a greenhouse gas and something that when it gets into the atmosphere can lead to a rapidly changing globe. This really impacts us as a society. So it's not just an esoteric question of like, what do worms eat in the bottom of the ocean, which if you'd like to talk about, I'd love to talk about for hours, but I won't. But at the same time, it starts bringing in this, like, this is what the ocean does for us, right? These microbes, they eat greenhouse gases for food. And that means that we can live on this planet, because if they weren't eating it, we couldn't live here. It would be too warm.
Yeah.
Are there many methane seeps in the deep sea? And is that a normal part of the ocean floor?
So when I started studying methane seeps, which was not that long ago, we knew of about 10 off the coast of Oregon, Washington, and California combined. And now we know of about 3,500.
Is that because there are more, or because we know how to find them?
Because we know how to find them.
Yeah, we just didn't realize that they were everywhere.
We didn't realize they were everywhere. And, the number of times that we've actually looked in the deep sea, we haven't peered into most of the depths of the entire planet.
So how far does sunlight go into the ocean? Because I guess most of the ocean is deep.
Where we are.
So does that mean that all of that is fueled by chemistry?
So we've done some calculations on the amount that's fueled by, so methane seeps are one, and then we also have these hydrothermal vents, which is superheated fluid that's also dragging chemistry out of the planet as another energy source for microbes.
Think like volcanic stuff, like deep underwater. Okay.
Cataclysmic, it's awesome to watch. And that fuels about 10% of the entire ocean is what we think. That's our best estimate, is 10% of all the energy. The rest of it comes from the sunlight that then sinks down.
Yeah, so the majority of life in the ocean is fueled from sunlight and stuff at the surface.
Yeah.
But say 10% of it is big earth science happening at the bottom, like crazy stuff coming out of the core of the earth.
And one of the really cool things about that is that chemical sources, they're constant. So there's not seasons in the amount of energy coming out of the seafloor. And so we've even found, when we've looked, that things like snow crabs off Canada, they'll come and spend time at methane seeps. And it might be when there's no sunlight-fueled energy from the surface, they might use it as sort of like that stop-in snack bar while they're waiting for the next food from the sun.
Yeah, so they eat the creatures that are eating the methane?
Exactly, yeah.
Yes, it's like an alternative food source.
Yeah.
But a lot of the food is raining down from the surface initially.
From sunlight.
Yeah,
Nice.
All that production in the upper ocean.
Okay, well, it's only taken some time, but I think I understand what you guys do now. So talk a little bit about your current work, I guess. Like, what's the Rolex National Geographic Perpetual Planet Ocean Expedition? Like, is that in the Southern Ocean? And were you guys together on that?
Yeah. We were on there with several of our colleagues. I can't remember exactly, maybe 25, 28 of us, our teams, but there's 6 or 7 of us.
28 people on a boat?
Yeah.
For how long?
3-4 weeks?
Yeah.
Almost 4 weeks.
Yeah.
Almost 4 weeks. That's the science party and then the crew.
Yeah, we call that a short trip.
Yeah, that's a short one.
Okay.
Yeah, anything that's shorter than a couple of months is short.
Okay.
Yeah.
For the polar regions.
And what were you guys studying on the boat? Or everyone was working on their own?
I think Andrew mentioned this, that we kind of are connected from the surface ocean, from like the sea ice of the polar regions, all the way to the seafloor. And that was sort of the goal of our cohort in this Southern Ocean expedition, was to study the ecosystem all the way from where the ocean is interacting with the atmosphere. There's a layer of sea ice, and then the organisms that live there, and then the things in the water column, and then, of course, the deep, dark benthos.
Yeah.
Dark benthos.
Yeah. In benthos is seafloor. That's
But it sounds so
happy
fancy.
Place. Yeah.
It's fancy.
Yeah. So one of the things I loved about the Southern Ocean expedition was that we had these explorers from all over the world that each studied a different component of the ecosystem. So we had people studying marine disease and birds, capturing penguins and seals on a daily basis. And then others of us would study the sea ice and the deep water and then the seafloor, and then even people trying to sample the deepest habitats of the Southern Ocean. And so it was this way to take people all over the planet with complementary expertise to try to tackle ecosystem scale questions and processes at once, which is also amazing because it's easy to work within a country of scientists, but really we want to study the globe collaboratively, and scientists love to work across borders. And this was an opportunity where we could have amazing scientists with different lived experiences that all allow us to understand these ecosystems in ways that we couldn't if we just take, what I know about an ocean at that advanced science, but not like when you have somebody from Argentina or someplace else where it's like different views.
So what's the role of the National Geographic Society and the role of the Rolex Perpetual Planet Initiative on your work?
The role of the National Geographic Society on our work is that it really allows us to communicate and amplify a lot of the challenging problems that we've seen that we haven't been able to do to this date. And really, this was exemplified by the Rolex and National Geographic Society Perpetual Planet Southern Ocean Expedition, because it was this sort of audacious plan to get scientists from around the globe, each studying a different component of the ecosystem, put them on one boat and have them tackle an ecosystem, seashore to seafloor understanding of the planet in this part of the planet that's so far away that people don't appreciate how it impacts with their life, and also is gorgeous. Like, it's icebergs floating by on a beautiful sea. You get down to the bottom of the ocean, you see these expansive, beautiful biomes that are untouched, and at the same time, part of this functioning planet. So both the Rolex facilitating in collaboration with the National Geographic Society has allowed us to work in new, novel ways with colleagues that are now great friends across the planet.
Yeah. And I would say that it's a rare combination when you get two entities that believe in a shared vision and then say, hey, let's put together our resources, let's drive this vision and empower the people to that can do that work, to do that work and to do it together. So that's the role of the Rolex Perpetual Planet and National Geographic Ocean Expeditions. And the work that we can do through those resources is just incredible. It's phenomenal.
Did it help you think about your work differently in any way, or do you see anything interesting where you're like, oh, wow, they've...
It's the best of both worlds. You get to do your science and be the expert there, but then the flip side of it, which is what I think is the better part, is you get to be surrounded by people who are incredible at what they do, generous with their knowledge, and tell you why they're excited about what we're studying together. And that's super cool.
Funny, that reminds me so much of climbing expeditions, where it's like, oh, you get to go on a thing with other people who are the best at what they do and learn from their thing. I'm like, yeah, like literally my first trip to Antarctica was with Conrad Anker, who'd been on the cover of National Geographic on an expedition to Queen Maud Land like 20 years before. And so you're like in roughly the same region with the person whose cover story inspired you to want to go there. At some, you're just like, this is so epic.
This is so epic.
He's like serving you tea in your tent, being like, okay, let's go climb a mountain. And you're like, oh my God, it's so cool. It's like totally the same kind of, you're like, people will pay me to do this. This is amazing. And I'm learning so much.
And that feeling never gets old. For me, that feeling never gets old because, as Andrew was saying, the diversity of science that we do is one thing, but our lived experience and who we are and what we bring to our work really makes it special because you can't replicate that.
Yeah, what do you feel like you gained from the community and on expedition?
I think one of the things I really gained from that expedition was really appreciating the drastic change the planet's experiencing across many different parts of the ecosystem from the sea ice. Because normally when I go on an expedition, I work in the deep sea. Like, we take in a remote operated vehicle, we send it to the seafloor and we study it. And this, I got to see the changing ice, the challenges that Ali and colleagues and new friends were facing. And one of the things I love working in Antarctica, and this was a great example of it, is it's governed internationally. And so it's a perfect place for countries to work together cohesively across all components of the ecosystem to try to conserve it, to try to figure out what are the solutions? How can we actually come up with solutions to these great challenges that are facing us as a society? And it's not one component of the ecosystem. It's all the components of the ecosystem that need to be viewed together. I mean, we're looking at what are the connections between the sea ice and the deep sea? Those connections are real. Yeah. But if you don't have scientists that study both of those, usually having dinner or lunch together, you just don't make those connections.
You never think to look.
Yeah.
Huh. Yeah. Where does science communication fit into all this for each of you guys?
The types of visuals that we're able to produce now of these places, especially like sea ice, something that people never probably think about in their everyday life, that we're maybe never able to touch, and sort of giving them a sense that that ice is not barren, that ice is alive.
That's a hard thing for people to visualize.
Yeah, it's really hard.
I spent a lot of time on that type of ice. I'm still like, are you sure it's alive? I'm like, I don't know.
Sea ice is certainly alive. Ice sheet ice, there's bits and pieces of life here and there. That's a different beast.
Why is that different?
It collects, right? If you go outside and look at the river, and it's got all of this material that's caught up in it.
Most of the ice that I suppose I've interacted with in places are basically icebergs, like things falling off glaciers and sort of like frozen land mass floating out to sea.
Ice that's hundreds of thousands of years old.
Yeah, that's totally different.
But sea ice is like ice that's a year or two old.
I
right?
see.
For
yeah,
instance,
it's the surface of the ocean that froze.
It's the surface of the ocean that froze.
So it's like a snapshot of what was in the ocean at that moment.
Yeah, exactly.
Yeah, I think communicating science is a challenge for everybody that does science because we get so ingrained in the particulars of it.
Yeah.
The other thing that I really try to do is put a lot of our results in the context of how it benefits society. You know, because we forget that everything we do really has an impact on the ocean, but the ocean is why we can live on this planet and the reason why we can get food from it. And there's a lot of different ways that we're being asked to manage it differently, and we need to have that understanding. And so putting it in a context that's approachable and understandable to people is something that I strive for in my work, and then communicating that in any avenue or venue I can.
What do you guys see as the role for sort of next generation? Like, where do you see your work going? How do you see bringing people into this work to sort of take the next steps in it?
I love my job. I don't do the same thing 2 days in a row. Like, I get to teach, I get to mentor some of the most brilliant minds that I learned from my students more than they learned from me. And I also get to sometimes nudge some of those people that were going to be doctors into instead tackling some earth science questions, even though they probably would have been great doctors. But I can set somebody on a different path.
The world has a lot of doctors who are like, whatever.
Yeah, and
it's fine.
And so I think education and really knowing that science can be an incredibly fulfilling career.
Yeah, I mean, I think for myself, it's really about getting more people to understand the value of scientific information, right? So part of it is bringing more people into the field of science and having science as a profession that's respected and something that people gravitate towards. But I think the other thing is like, if you are science-minded, you don't have to become a scientist to still utilize that kind of curiosity and critical thinking. We need that level of critical thinking and logic in all professions, right? We need that in civics. We need that in law. We need that in industry. We need that everywhere. We need people who are really good at sort of disentangling complex stuff and being like, hey, this looks like we can solve it this way. And being creative and being curious. And I think that's where science does really, really good work.
You frame it in that way, I'm like, oh, that does seem very appealing. I'm like, I want to find order and chaos. Like, I want to help make sense of the world. Like, that is a very good way to draw people into science.
I think the other thing that I like try to communicate about science is a scientist's core job is to prove themselves wrong over and over and over again. It's just essentially every single time to test what you think you know and show that that idea that you had that you thought was brilliant is absolutely wrong. That's the scientific method right there.
Yes, absolutely.
And I think if we approached life in that in many different ways, it would actually be great. If you just were ready to prove yourself wrong or be proven wrong constantly, I think that's one of those life lessons that I know I could learn more.
Certainly instills a little humility when you're just like always wrong. Yeah, it's funny. There's so many things you guys are saying that just draw me back to climbing. And normally I actually don't really talk about climbing in interviews, but the thing with climbing is like you basically fail nonstop. Like you're always trying a project.
Science is a lot of failure.
Yeah, it's like you try a project like for months sometimes and you basically fail every day. And then the one day that you do it, you're like, I succeeded. You know, I like climbed a thing. It took me 7 minutes. I've been failing on it for 6 months. And then I had 7 minutes of success. And then you move on to the next project where you fall on that for the next couple months. Yeah. And it's sort of like, yes, I mean, science seems like the same thing where you just like beat your head against it.
Failing.
I've done projects that are like 6 years of failure. And then all of a sudden you're like, wait.
You're like, I didn't fail for once.
Fail
you're like,
time?
that's not, that seems wrong.
Like, now I need to prove myself wrong again. No.
Totally. Well, the power of failure, that's the beauty of
chaos and failure.
Yeah. So next week, I'm going to be joined on the podcast by Katie Croft Bell and Sheena Talma. Tell me about working with them, or what should I ask them about? What should people listen for?
So
give me salacious gossip, something like.
Indeed.
So you're going to get to meet with two of my favorite people.
Okay.
And the reason is because Sheena and Katie are at the forefront of shedding light and vision on the deep sea. Sheena works from the Seychelles and essentially is opening up the entire Indian Ocean deep sea to understanding how it works, the beauty, the craziness, all the amazing life. And then Katie has essentially spent years just trying to create facilities for people to peer into the depths of the ocean. And so we get this global understanding of our entire planet. 60% of it, almost none of it's been seen. And that they're both just pushing the forefront of it. Yeah. And actually one of my favorite parts of being part of the Perpetual Planet community as through the National Geographic and Rolex is that I get to work with people like Sheena and Katie, who together we can really span the entire global ecosystems.
Andrew, Ali, thank you guys so much for taking the time to be on Planet Visionaries. It's amazing chatting with you today. Is there anything you'd like to close with? Anything you'd like to add?
Just thanks for the opportunity to talk. I think that one of the things I love the most about this planet is the beauty in every component of it, and how the more we view this globe as one ocean, connected to the atmosphere, connected to the people, the more we can appreciate the importance of treating it with respect and appreciating every person as well as all the life, the entire planet over, even the frozen bits.
Save our oceans, care about the science, take good care of your scientists.
Cool. Thank you, guys.
Thank you so much.
Andrew, Allison, thanks so much for speaking with me. We'll put links to your work in the show notes. Next time on Planet Visionaries, we meet with two other scientists making waves with the Rolex and National Geographic Perpetual Planet Ocean Expedition. Did you know that we've only discovered 0.001% of the ocean floor? Katie Croft Bell intends to change that, and Sheena Talma will share her plan for the first locally driven deep ocean expedition in the Seychelles. Planet Visionaries is a podcast in partnership with the Rolex Perpetual Planet Initiative and a Sony Music podcast production.